Okay, picture this. It's October 20th, 2025. You grab your phone to do, well, anything, and nothing works. It wasn't some big cyber attack, but it sure felt like one. It brought down some of the biggest apps and websites in the world all at once. So today, let's dig into what really happened on the day the internet pretty much stood still, and what it tells us about the, maybe, fragile foundation of our digital lives.
So just think back to that Monday. Maybe you were trying to jump into a game or check your bank account or even just send a message and poof, nothing. It wasn't just you. For millions and millions of people, it was like the digital world just froze, all at the exact same time.
And I mean, just look at the list of services that went dark. This was everything. We're talking fun stuff like Snapchat and Fortnite, but also serious things like the crypto exchange Coinbase, major banks, even the McDonald's app. This was not a small glitch, folks. This was a massive shock to the system that hit pretty much every part of our online lives.
And if you want a number to wrap your head around, the monitoring site Down Detector got more than 6.5 million, that's million with an M, outage reports from people all over the world. So yeah, this wasn't a few people with bad Wi-Fi. It was a huge global disruption.
So the big question is, what on earth could cause a chain reaction like that? To figure that out, we've got to peel back the layers of how the modern internet actually works.
Turns out the whole problem started with one company, Amazon Web Services, or AWS. The best way to think about AWS is like the landlord for a giant chunk of the internet. They own all the digital property. You know, the servers, the databases, all the plumbing that thousands of other companies rent to build their apps on top of. And when your landlord has a problem, well, every single tenant feels it.
And you could see this happening in real time. You had CEOs from major tech companies, like Arvind Srinivas from the AI startup Perplexity, basically tweeting out, hey, it's not us, it's AWS. They were telling everyone that the problem wasn't their code, it was the foundation they built it on. Their hands were completely tied. And the scale here is just mind-boggling. AWS controls about a third of the entire cloud computing market. Now, that kind of dominance is what makes everything so efficient, but it also creates this one massive single point of failure. A tiny problem in one little corner of AWS can send shockwaves across the entire global economy.
But let's zoom in a little bit. The failure didn't actually hit all of AWS at once. Investigators traced it all the way back to one very specific, very important region, US East 1. That's a huge cluster of data centers in Northern Virginia. And because it's one of the oldest and most important AWS regions, a ton of global services rely on it, even if they aren't directly hosted there.
And man, this thing spiraled out of control fast. It all started quietly at 3:11 a.m. Eastern Time, with some errors in that Virginia region. Less than an hour later, services all over the planet were feeling the pain. It took engineers more than 3 hours to get the main issue totally fixed, which just goes to show how quickly a local problem can become a global nightmare.
Okay, so the technical smoking gun was something called a DNS resolution failure, and it happened inside a core database called DynamoDB. Just think of DNS as the internet's address book. It tells your app how to find the server it's looking for. So when that address book broke for this one crucial service, apps just got lost. But here's the real mystery. A little DNS hiccup like that shouldn't cause a global meltdown. Something else was at play, keeping the whole system broken. And that brings us to the real villain of this story.
All right, this is where it gets super interesting. The outage wasn't just a simple break-and-fix situation. No, it was kept alive by this nasty, vicious feedback loop, a hidden pattern that can turn one tiny little problem into an absolute catastrophe.
And this pattern has a name. It's called a metastable failure. Here's an analogy. Imagine you've pushed a huge boulder right to the very edge of a cliff. A tiny nudge, that's our DNS glitch, sends it over the edge. But instead of just crashing at the bottom, it triggers an avalanche that just keeps growing and growing, all on its own. The system gets stuck in a state of failure, and it's powered by its own downward spiral.
It all happens in 3 stages. First, you've got your stable state, where everything is fine. The system can handle little blips, no problem. But, to save money and get the most performance, systems often run in a vulnerable state. Everything looks fine, but they're running so close to the red line that any tiny trigger can push them into that third catastrophic state, the metastable failure. And once they're in it, they can't get out by themselves. So here's exactly how that feedback loop worked. Step 1. A request to the database fails because of that initial DNS glitch. Okay, so what does the app do? It's programmed to automatically try again. But now, all of a sudden, the database is getting hit with double the traffic, the original failed request plus the retry. This extra load makes even more requests fail, which, you guessed it, triggers even more retries. It's a death spiral. The system is literally suffocating itself trying to recover.
So if these kinds of failures are even possible, how in the world do we build a stronger, more resilient internet? Let's switch gears and talk about the strategies that can actually prevent this from happening again.
The very first thing you have to do is define your goals for recovery. And it starts with a really simple question. How long can you afford to be offline? That's your recovery time objective, or RTO. And this is so important because for 98% of organizations, just 1 hour of downtime costs over $100,000.
The next question is just as critical. How much data are you willing to lose? That's your recovery point objective, or RPO. So if your RPO is, say, 15 minutes, that means you can never, ever lose more than the last 15 minutes of customer data. The smaller you make that number, the more robust your backup and recovery system has to be.
And to actually hit those goals, you've basically got two main strategies. The first is multi-AZ, which just means spreading your app across a few different data centers in the same city. That's great for surviving something like a fire in one building, but for a massive outage like the one in Virginia, you need a multi-region strategy. That's where you literally duplicate your entire setup in a totally different part of the world. It's way more complex, yeah, but it gives you a much higher level of resilience. And the payoff for doing this right is huge. I mean, look at these numbers. A good multi-region setup can cut the financial cost of downtime by over 95%. It can reduce unplanned outages by more than half, and it can boost your availability to that magical 4 nines. That's 99.99% uptime.
Okay, so let's zoom all the way out. This whole event points to a final, really important takeaway. It's a kind of paradox that sits right at the heart of the modern internet.
Here it is. We rely on just a few giant cloud companies like AWS because that centralization is unbelievably efficient. It lets a tiny startup use the same world-class infrastructure as a global bank. But that exact same centralization is what creates this massive fragility, where one little hiccup in one data center can bring the whole world to a halt.
Which really leaves us with this one last question to think about. As we keep building more and more of our society, our money, our conversations, our entertainment, on top of this powerful centralized cloud, are we actually building an unbreakable network? Or are we just building this incredibly elaborate digital house of cards, just waiting for the next little gust of wind to send it all tumbling down?